Welcome, everyone, and thank you for attending the 2021 inaugural EGW Utility Solutions Conference. We know how valuable your time is, and we're grateful you've chosen to spend it with us today. Before I introduce Mark Cangany to speak about advancements in rotary meter technology, I want to point out a few quick things. First, I just want to let everyone know that this session is being recorded. Second, as you may or may not be aware, we're giving away a door prize for every session throughout the conference. For this class, Flow Meter Group has graciously donated a $100 Visa gift card. We'll choose the winner from the list of attendees to each session. So please make sure you've logged in with your correct email and contact info so we can reach you with your prize. Unfortunately, Microsoft Teams does not allow us to unmute individual attendees, so all of your mics will remain muted throughout the presentation. However, you can still react or interact with the presenters by asking questions using the Q&A. If you look, you should see a button at the top of your Teams screen that looks like a question mark in a bubble. If you click that and type in a question, it'll come to me. I'll gather the questions, and at the end of the presentation, I'll ask those to Mark so he can provide your answers. If we run out of time before we get to yours, don't worry, we'll do our best to contact you with answers next week. Feel free to submit questions as they come to mind throughout the class, and don't worry because submitting questions won't interrupt Mark's presentation. So we encourage you to send as many as you want, as often as you'd like. All that sound good? Great. Without further ado, I'd like to introduce Mark Cangany with Flow Meter Group. Mark was born in Indianapolis, Indiana, and has been involved with the natural gas industry since 1986. With a background in industrial instrumentation and controls, he moved to Houston, Texas in '97 and worked for Dresser Industries, began working as a technical training and field engineering specialist. Mark joined Flow Meter Group in 1996, where he specializes in sales and technical for the US and Canada markets. Thank you for joining us today, Mark. The floor is yours.
So the rotary meter has been around for many years. In fact, dating back to the 1600s of the 17th century. The Pappenheim engine was the first documented lobed kinetics machine that was ever utilized. Many of us here in the United States, that wasn't even an option for us. So a German engineer, Franz Reuleaux, did the first design and build of a rotary, what they called kinetics machine. Where it became famous and most useful was two brothers in Connorsville, Indiana, known as Francis and Philander Roots, who tried to make an encapsulated water wheel out of wood, which obviously didn't work. The wood got wet, it swelled, it stopped. A couple of days later, which allowed pressure to escape, and as the saying goes, it blew the hat off the head of Francis Roots. And that is where it starts in the 1850s here in the United States. Simultaneously, there was a group in Europe that developed the same identical machine, the blower, and there's absolutely no way that the Roots brothers or the group in Europe had any knowledge of each other. It just happened that way. So what we know today as the Dresser rotary meter is an adaptation off of the Roots blower. That was, the blower design was changed in the 1920s. Better bearings were used. Instead of a motor, an odometer was put on the end, and that's where the first high capacity Roots meter came from. So advances, there have been many advances since the 1920s in the arena of measurement in general, but specifically with the rotary meter. So today what I'd like to talk to you about is just the rotary meter. but I'm going to point out a little bit about Flow Meter Group. So Flow Meter Group was founded in 2009. It's headquartered in Doetinchem, Netherlands. Our meter portfolio is rotary meters, turbines, ultrasonics, transfer provers, flow computers, and even volume correctors. So the meters range in pressure classes from ANSI 150 to ANSI 300 to ANSI 600. Years ago, the only thing you could get was an ANSI 125. Our standard in our industry today is an ANSI 150. And many sizes, anything from 1.5 inch, 1.5 M to an 8-inch 56 M, all line mounted. For those of you that have been around rotary meters for a while, anything above 38 M, 56 M, 102 M were all cast iron foot mounts. That's not true today. So we take a 56 M through a lightweight for aluminum line mounted meter. Some of the meters can come in different styles for you. Whereas before, a typical 5M was only a 3-inch connection and 7s and 9s were 4-inch connections. Now the accommodations are made 5M through 9M to get them in either a 3-inch or a 4-inch fashion. That was not available even 10 years ago, well, 12 years ago. So the principle is the same: 2 contra-rotating impellers inside the meter. 1 full revolution of these impellers gives you a known volume from the inlet to the outlet. And it is considered a positive displacement meter. A turbine would be a good example of an inferential meter. This is not it. This is a positive displacement in the same class of measurement as a diaphragm meter. There are no physical mechanical seals inside of a rotary. All rotaries run on the same basis of specification of distance between the impellers and the inside wall of the measurement chamber. As the impellers turn, you can see the wiper in the middle, and then 2 low spots, one before and one after the wiper. As the impellers turn, those low spots create what's called a fluidic seal or a capillary seal. It is as tight as a mechanical seal. So leakage across the impellers is pretty much non-existent. Will it leak at a very low rate? Yes, but it's minimal. And that is true with any rotary meter. The length and width of the impeller determines leakage. That is all taken care of or looked at with a mathematical formula. For those of you that are bored and would care to try it, go right ahead. Turn down ratios. Turn down ratios vary on the size of the meter and the medium that is going through the meter, whether it be air, natural gas, or any number of gases that are typically monitored by a rotary flow meter. Here's one of the biggest changes over the years in rotary meter design. Typically, a rotary meter was put together that you had to completely take every piece apart of the meter to repair it or to check it. Take the FMG, for instance, we have a cartridge design. So only one side of the meter requires oil. There's still 4 bearings, but the bearings on the back side do not require any lubrication. They are considered permanently lubricated bearings. So once you pull the head cover off, you can actually pull the cartridge out, inspect it, clean it, repair it, clean the inside of the meter, and put it back together. This is the only meter on the market that you're available to do that with. Another quick change, well, I shouldn't say quick, but a big advancement is gear reduction. So the meters will turn at a known rate, and somehow we have to get those impellers turning to relate to cubic foot or cubic meters of flow through the meter. On all manufacturers except us, that gear reduction is done in the index. With the FMG meter, one huge advancement was putting that gear reduction on the cartridge of the meter. So what does that mean to us? That means that if I have an 8C or a 56M, the index is the same. There is no specific index per meter. With all other manufacturers, if you have a 3M meter, you better have a 3M index to replace. Will a 5M physically fit on a 3M? Absolutely. But now you've got gear reduction problems. You do not have accurate accumulation of the measurement. With the FMG meter, we took that out. We took that problem completely away because you cannot put a 3M cartridge in a 5M body or a 5M cartridge in a 3M body. All the gear reduction for the index is done on the cartridge itself. Another huge advancement, and this is a patented advancement, I might say. The impeller on the top is a conventional 3M. The one on the bottom is an FMG 3M. If you'll notice, the width is much smaller. The height is a little taller. The robustness is taller, but the width, the real estate of the actual impeller is much smaller today in an FMG meter than even a conventional rotary meter that's produced by other manufacturers today. Also, the shaft for the impeller, much thinner on a conventional rotary meter, much thicker and much closer that you're able to put the gear to the impeller, which again makes it a more robust meter, less likely to spin a bearing, less likely for lockup. Again, a huge advancement in the rotary meter market. Leakage, we'll go back to that again real quick for those of you that love math. The tolerances are 2/1000 of an inch. So very, very minute tolerance. Here's an actual application for the patent for our square impeller, as we call it. Our chief engineer, Raymond Richards, was awarded a patent by the European Union for his design on these impellers. So throughout my presentation, you'll see both G values and what we call imperial values. G values are typically used outside the United States. The imperial 3C, 5C, 5.5M, those are imperial values. So you'll see both of those in the presentation. And the reason I do that is we're starting to see where companies in the United States are asking for meters by G value. So let's talk about sizing and overload. So typically a rotary meter, especially on a dynamic flow, is the best choice between 800 cubic feet an hour and 56,000 cubic feet an hour. It follows a profile simply because it's positive displacement. In the FMG series, you'll see where the accuracy goes much lower than a typical rotary meter. Where a typical rotary meter is accurate down to 20% of its flow, we're accurate to 2% of our flow. I don't know if this particular slide is going to work, but I'm going to give it a try. And for those of you wondering what that noise is, this is a 5.5 M running at 23,000 cubic feet an hour, 400% of its designed load. So yeah, it'll be noisy for a minute, but I think you'll understand. Let me get back over here. So as you can see, that odometer looked more like a stopwatch running than a gas meter running. So a 5.5 M meter running at 400% of capacity, and then a test was run on that meters after it was done, and the meter remained perfectly accurate and no damage to the meter itself. That cannot be done by any other meter other than FMG. A huge advancement in the technology of rotary meters. While everyone else requires a restrictive orifice plate downstream to restrict their meters to 120% of capacity, with the way that our company has advanced rotary technology, that's no longer an issue. So huge change. Another big advancement in rotary meter technology is oiling the gears, oiling the bearings. As I said earlier, only one side of this meter has to be oiled. In all other manufacturing and throughout history with the rotary meter, both sides had to be oiled. So both sides had oil reservoirs, and they used an oiling system called a vane. So it's a strip of metal that is attached to the end of an impeller. As the meter flows and the impellers rotate, the vane dips down in the oil, throws the oil up to the top of the cavity, and then you hope that oil gets to where it needs to be. In high speed an issue with high speed on rotaries, conventional rotaries, it often caused the oil to get into places that you didn't want it, and it would begin to siphon out and go downstream. As you can see in this particular slide at the bottom, there is a low speed oil gear. It sets in the oil, it picks up oil on the teeth and passes it upwards to get to where it needs to be. So the gears are oiled and the bearings on the instrument side of the meter get the oil they need, and it goes where it's designed to go, not where you hope it'll go. Again, another huge advancement. Not sure what just happened there. So with optimized lubrication, now you can check the oil every 5 to 10 years or whatever your state and company standards are. We suggest 5 to 10 years because we know the oil is going to stay where it was designed to be and not thrown downstream. So some other advancements with the rotary meters today is an aluminum double wall. All of our aluminum is anodized inside and out. So painting is not an issue. You don't need it. A lot of companies still paint them, and that's fine, but it's not needed as it is with others. We use a polycarbonate glass window. It is UV resistant, and it's a much bigger window to be able to see the read on the meter. In conventional rotary meters, there is one position for the index. With the advancement that FMG has been able to incorporate, there's a 350-degree rotation. So you can base that index how you need it instead of, gee, I wish I could do that. So just a minor adjustment, and it does not interfere with the accuracy of the meter. It just makes it easier to read the index. Instrument drives are reversible, and that's been a good advancement for everybody. And I don't care who the manufacturer is. The question is, how easy is it to do? My personal opinion, and I've worked on all of them, I think the FMG is the easier way to change direction of the instrument drive. If you need clockwise and it's set up for counterclockwise, it is an easy change, and vice versa. We also can incorporate contact closures in the index of the meter, typically low frequency, but they are there. We are the only manufacturer that can supply a tamper switch. It doesn't happen much here in Texas or in the south of the United States, but the Pacific Northwest and up in New England, they're starting to see tampering with the actual index. Without getting into detail and giving potential ideas out, just know that we have an answer to that. This was developed because of problems elsewhere in the world, and it is now available to anybody that utilizes FMG product. I think another big advancement is the oil sight glasses. So we put two in, whether you're putting in horizontal or vertical, you have a sight glass. Also, we put in an optical disc so that when you go to prover test your meters, you're picking up the information directly from the impellers. Through an optical disc, that plug that's circled in green can be removed, and an optic sensor can be put in place so that you can run your prover test on the meters. They can also be set in multiple positions. And as you can see, our bolts that protrude can also have a security seal put on. We have both temperature and pressure taps on the meter. With a typical manufactured rotary meter, you can see how many places are available to get into that meter and tamper with it, whether that be adding grease, trying to defeat the magnetic couple. Some people will go in and actually cut impellers. It is very difficult to get into an FMG meter. I think that is a huge advancement for the integrity of the meters today. So as you can see, all the plugs are sealable so that it's a little more difficult, but as my grandfather, who was a retired police officer, said, locks only keep honest people out. So we can put tamper seals on everything, but if somebody wants to get in and mess with a meter, they're going to do it. Another huge advancement in the rotary meter market is the availability of an integrated bypass on the meter itself. So FMG is the only company that offers that. As you can see, the black hockey puck on the end of the meter, that is an automatic bypass. We have seen in many cases where a conventional rotary meter was being used, the meter locked up, the customer or even the town lost gas supply. The way this particular bypass works is if the differential goes high, the bypass will open. It is a mechanically resettable bypass. This bypass also has a contact closure. So if you're running this through a flow computer or even a volume corrector that has communication, you can send that contact closure to your electronic device that can then notify someone. Control room, call a pager, text, whatever. So it is a full capacity. So if your meter is a 3M, you'll get 3,000 cubic foot of flow through there. So your critical applications are not lost. As I said, it is resettable mechanically. You can see on the left-hand side, the bypass is closed. On the right-hand side, the bypass is open. If you look closely, you'll see what looks like an oil sight glass, and directly behind it, a steel pin. So if you're out at a facility and you think the meter's in bypass, look at that sight glass. If you don't see anything, it's not in bypass. If you see that steel pin in the window, you know it's in bypass. This particular advancement in rotary meters has made a huge difference on high capacity. So I don't know how many of you are familiar with getting a pulse downstream of a rotary meter when it's running, especially at high capacity. That's just the nature of the beast. 2 impellers, it pumps. It becomes a pump at a point downstream. What FMG has been able to do is put 2 sets of impellers inside, and they are offset 45 degrees. So you get a smooth flow downstream of the meter, not a pulsing or a puffing, as some people call it. So the two together, the 2 sets working together, but again, 45 degrees out of phase, gives you a smooth transition from the inlet to the outlet and further downstream. This is what it actually looks like. Very simple design, but a huge advancement, especially in boiler applications, in large industrial applications. This meter takes pulsation out of the line. Also available are different sizes. Our ANSI 300 has a maximum pressure of 500 PSI, which is higher than most. So this is a typical natural gas filling station for cars and trucks. Our meters are quite common there. They can take the load of 0 to 100% and back down again very easily. And again, without the restrictive orifice plate. High pressure meters. Again, a huge advancement in that they are cartridge design. So once the main meter is put in line, If for some reason there is an issue, you can pull the cartridge and leave the body in line. We do supply cartridges, and the pricing varies on those. The cartridge exchange is pretty easy. I have done it. Several of our customers have done it, and very quick change out. Even with our ANSI Class 600, there is an option for a bypass. Again, critical applications, you cannot lose the gas supply. The spring-loaded bypass will allow you, if the instrument locks up, the bypass will open, your customer stays up and running, or your town stays up and running. We've gotten several calls where in the middle of the winter, 30 below zero, a rotary meter failed. They cut the supply to a town. Wasn't intentional, it just happened. With the advancement of the bypass and the availability of it, that problem is no longer a problem. So ANSI class can run anywhere from a 2.5 M to a 16 M. Again, easily installed, typical meter installation. The difference is if you need to service that, you don't have to pull the complete body out of line. Pretty easy to take apart, much easier than anybody else's. Again, it's engineering design advancements. So as with all other meter manufacturers within Europe, everything has to be NMI and ASL approved or OIML approved. We use NMI to do that approval. Any questions?
Mark, thank you. That was awesome. I do have several questions.
Okay.
First question was, is the maximum working pressure for a 150 ANSI meter 285 PSI? Aren't most meters, rotary meters, rated at 175 PSI?
They are, but that's a true ANSI 125, not an ANSI 150. So an ANSI 150, we rate ours at 285 PSI and certified by NMI and other international laboratories.
But other meter manufacturers are usually saying ANSI 125 because that's the main reading they've got, or the main approval, and it limits them to 175 PSI.
That is correct.
Okay. Another person asked, what does turn down ratio mean?
So turn down ratio, as it was explained to me many years ago, is, that the capacity, the 100% capacity, how low can I go and maintain a known accuracy? So
Okay.
if you have a 5M meter, which typically would be 5,000 cubic foot an hour as a maximum, okay? So if we take that 5,000 and we divide that by 120, that means I can go down to 41.67 cubic feet an hour and still remain 1% accurate.
Okay.
That's at a turn down of 120 to 1.
And how does that 120 to 1 compare with other options on the market?
I would say we're, in some of the sizes, we're identically the same, and in others, we're a little bit better.
Okay.
I can't say we hold the record on it. I'd love to, but.
When you were speaking earlier about running at 400% capacity, someone asked, can the meter be run at 400% capacity indefinitely?
the short answer is no, I would not do that. So here's a perfect case in point. Commercial bakery in the Netherlands, they start up at 4 o'clock in the morning. For 2 hours every day, their meters run at 165% of capacity, I believe, until all the ovens are up to temperature, and then the gas flow slows down. So all day through production, the meters are running 70, 80%, which is pretty normal. But for 2 hours every day, they're overspun. And that doesn't hurt the meter. Let me rephrase that. It doesn't damage the meter. So a meter that is designed to be out in the field for, say, 30 years, mathematically, this has been done. Obviously, the meters have not been in the field long enough, but mathematically, if the meter is designed to be in the field for 30 years, you overrun it 2 hours a day, that meter will now be good for 25 years instead of 30. I know of 2 places here in the United States that overrun those meters 40% occasionally, an hour a month, 2 hours a month. The meters are fine. It, again, because of the robustness of the shafts, the square of the impeller, the bearings, the overspin is not as important as it is to other meters.
Okay. Why are the bearings in the back of the meter considered permanently oiled?
Because we don't oil them. There's no way to get them any oil. They're permanently lubricated.
Gotcha. Another question says, did I understand correctly that no flow straightening devices have to be used in front of the meter? If so, how close to an elbow can the meter be installed?
You can go right up to the elbow. It's a positive displacement meter. So any rotary meter, whether it be FMG or anybody else's, you can put them tight between 290s. It's a PD meter. They're not influenced by non-laminar flow.
Okay. Another question says, is the anti-tampering capabilities you discussed standard in all meters?
No. Good question, though. So we have some utilities on the East Coast that are experiencing tampering that until last year, we only saw in the Middle East and Asia. We have been able to prove to several state PUCs that, because they came to us and said, okay, what are you going to do about this? And we said, what do you mean? What are we going to do? We've already done it. So we proved to them that what their concerns were are not affected. They will not affect our meter. And to add insult to injury to the person who's trying to mess with a meter, we can hit a contact closure and notify the utility immediately that somebody's tampering with the index.
Interesting. So that's something that if they were ordering a meter, they would need to specifically request the tampering?
Yes. So a couple of things that you would need to keep in mind when ordering an FMG meter is, do I need the tamper index? Do I need an index with a pulse output? Do I need a high frequency output? Do I need a bypass? All 4 of those we need to know up front, with the exception of the high frequency pulse. The hole's already drilled, so if you need to add it later, you can add that later. But the index, you can change the index out later as well. But the bypass has to be ordered with the meter up front. That is not field retrofittable. The indexes are, and the high frequency is, but the bypass needs to be ordered with the meter up front.
Okay. The last question that we've had submitted so far, which we still have time, folks, if you want to submit any more questions, feel free to do so. This last question asked, do you prove the meters before ship? And I just want to add myself, we do have some time left if you wanted to talk about your provers at all. I don't know if you have slides ready or you just want to talk off the hip, but if you want to add that to the answer to this question, I think we've got time.
Okay, so every meter that we manufacture, and the term prover, keep in mind, the term prover is only used in the United States and Canada. There are test benches outside the US and Canada. So every meter that's manufactured, and I don't care who manufactures it, us, Dresser, Romet, whoever, they have to test that meter, and you should get a proof sheet with every meter that you order, brand new. So what we do is we do that at the factory. We have had some customers, until they got familiar with us, say, hey, I want a test run here in the United States. I want to know what it looks like on our soil. Okay, no big deal. We have a test bench here. We can test meters. And our test bench runs from, and my boss will argue this point, but I've proven it to him. Our test bench will run from 16 cubic foot an hour to 88,000. That's our small test bench. The footprint of that test bench is very small. It's smaller than the average desk that somebody works at. So yes, they are done at the factory, as with all meters that are manufactured. A proof curve comes with every meter. And taking a step forward on that, we have had customers send us other manufacturers, whether that be Dresser or whoever, and we can test those meters on our test bench, and we can give them a flow curve. So our test benches, the smallest one we do that's available right now, maxes out at 88,000. We have another one that maxes out at 200. We have another one that maxes out at 350,000. And for those of you that are on LinkedIn, I strongly urge you to go to the Euroloop LinkedIn page and take a look at our latest test bench that we built for them that will test 570,000 cubic foot an hour flow. So we make our test benches in various sizes based upon customers' needs and wants.
Okay. Along those same lines, we just had somebody ask, is the test bench used at the factory to prove or to test your meters before they leave traceable to NIST? And then likewise, are the test benches that you sell traceable to NIST?
Okay, so that's an interesting question, and short answer is yes. But please know that the NIST standard for flow benches in the natural gas industry is actually held by the Netherlands Measurement Institute in Delft, Netherlands. NMI, or VSL as they're known today, certifies all of the test benches that we manufacture. Now, there's a big difference in the way that we have ours certified and others have theirs certified. We have the entire bench certified, which means the master meters, the blowers, and the electronics. So NMI comes to our facility and verifies all of that. With the other manufacturers, only the master meters are verified. So the answer is yes. As a matter of fact, the one that's in our office is considered first step. So it is one step away from the worldwide standard, which is the NIST standard and also the VSL standard.
Wow. All right.
You don't charge an arm and a leg for that stuff either.
The last question that we've received so far, I lied, we just got another one, but the next question is, are your meters AMR compatible? And I would add, are they easily AMR compatible?
My humble opinion, yes. So we can give you a pulse output, low frequency or high frequency. We also have an ID. It all depends on the AMR system. I have not seen one yet that we didn't work with easily.
Okay. The next question is, what kind of meters can be tested on your test benches? Can I test a diaphragm meter or a turbine meter also?
You know, when it comes to diaphragm meters, you can test up to 6 at one time. So yes, you can do diaphragm, you can do turbine, you can do rotary, you can do ultrasonic.
Fantastic.
If it's a flow meter in our industry, you can test it on our flow bench. You can
Okay.
even test orifice plates.
Wow. All right. Any other questions? We've got time. Don't feel rushed, but wanted to give everybody an opportunity to send those in.
Daryl, if it's okay with you, I'm going to quit sharing my screen for just a moment.
Okay.
And see if I can find that that PowerPoint on the flow benches. So at least you'll get a look at what one looks like.
Okay.
Maybe. There we go.
Bear with us just a second, folks. You get to look at Mark's beautiful face there for a minute, and then we'll get the PowerPoint back up there.
That ought to scare the bejeebers out of somebody. Well, here, if nothing else, we can take a look at the flow bench. I am not sure why my computer is running so slow today.
Only when you need it to be fast.
Of course.
While he's pulling that up, I'll go ahead and remind everyone that your attendance today has entered you in the drawing that I mentioned earlier. We are giving away a $100 gift card. So if you're the winner that we draw later, we will certainly contact you soon.
Okay, let's see if I can share this one.
All right.
So for those of you that are familiar with the Dresser 80M prover, this one has higher capacity and a smaller footprint.
I don't see anything shared yet. There he comes. All right.
All right, so here's what a typical flow bench looks like. Within this box, which again is smaller than the average desk that people work on, we can put two 38M master meters and what we call a split chamber 9M. So this will take us from just a few cubic feet an hour. Here's the split chamber 9M. So 9 cubic foot to 88,000. This is on our small bench. We make 3 other sizes. So you can see it's a very simple design, two 38Ms, the split 9M, and then we have a blower that sets off to the side. Everything is certified by VSL, the entire flow bench, not just the master meters. We have it all done. We also look at what's called uncertainty. So everything is manufactured to a specification plus or minus something. So we know what the manufacturing specifications are. We also know per component whether it runs to the high side of its acceptable limit or to the low side. We take all of that into consideration, and that's called uncertainty. No other manufacturer of meters or flow benches does that but us.
Awesome. Somebody just asked, has anyone in North America purchased one of your test benches?
Funny you should mention that. Fortis BC Gas. Yes. And if you'd like to see one, we have one available and would love to host you here in the Houston area. Our office is officially in Richmond, Texas, although I consider it Katy, which is just on the west side of Houston. So if you can make it to Houston, be more than happy to show you ours. This picture that you're seeing now, you see the computer screen. On this side of the header is an option to expand your flow bench up to an 8-inch fitting. You can do up to 6-inch here in the front, but you can go 8-inch on the side. So yes, Fortis BC Gas has purchased one. As a matter of fact, I had 3 of their people at our facility in Doetinchem, Netherlands. We had 9 of these running in production, in the production area, and everybody was talking at a normal level. Nobody was screaming. You didn't miss what the other person was saying. And then we had our largest one at the time running at 100% of capacity, testing some turbines for a company over in Germany. And that thing was running at 320,000 cubic foot an hour. And again, we were carrying on a normal conversation and we were standing within 2 feet of that test bench.
Goodness.
So you have 9 of these quoted here in the United States.
One other person asked, how do you feel about differential pressure testing for your meter?
Interesting topic. So even as an employee of Dresser, nobody could prove to me, and not that I'm any genius, nobody could prove to me that differential pressure meant anything other than the drop across the meter. If you go state to state, there are probably 40 different specifications on how to do differential testing. Again, the bottom line is, doesn't mean anything. Canada abandoned differential testing 20 years ago. Europe abandoned differential testing, my understanding, close to 30 years ago, because it has no actual meaning. Some people say, oh, well, it's the accuracy of the meter. No, because I've seen some pretty horrible differential and been able to prove or test that meter, and the meter was fine, accuracy wise. Some say, well, it indicates the health of the meter. I can argue that one too. If you want a differential pressure test our meter, go right ahead. With the test benches, we actually had a circuit added so that we could do the differential testing because it's required by so many state PUCs in the United States. So now when we test a meter, we show you what the DP was through the test. It has no concrete meaning. When I was with Dresser, I was not allowed to talk about that. I don't work for Dresser anymore. I don't mind talking about it. I have walked into several meter shops in one state where they hooked shop air to the inlet of the meter, had the outlet of the meter open to atmosphere, and took differential readings. You want to tell me what that proved?
Probably not much.
Well, kind of my thought. But it varies. It varies from state to state. Out of 50 states, there are 40 different ways of doing it. And at the end of the day, there's no valuable information obtained.
Got it. Well, all
So
right.
many countries have just abandoned it.
Gotcha. All right, everyone. Unfortunately, we're out of time for this session. Remember, if we didn't get your question answered, we will have saved it with your name and we'll contact you directly with your answer. Also, if you think of more questions after we leave here, or if you want to reach us for any reason related to this conference, please email us at events@egwusa.com and we'll be sure to reply as soon as possible. Of course, you can always reach out directly to your EGW territory manager or call our office as well, whichever you prefer. Like I mentioned earlier, you're all entered in a drawing and we'll contact the winner soon. Mark, any final remarks?
I would just like to say thank you to everybody. Your time is important and valuable, and I'm very appreciative that you chose to spend some time with us today. And I'd like to thank EGW. Not many companies have taken the time and the effort that these folks at EGW have done to put this conference on. And man, y'all did a stellar job. And the different classes that y'all offering, just outstanding. Thank you, Daryl. Thank you.
Hey, we did have one more question come in last minute. What kind of surface protection do your rotary meters have? Are they painted?
No, our rotary meters are anodized inside and out. They do come to you naked, if you will. It is just the anodized aluminum. On our high pressure, the steel casings are coated, but a standard rotary meter is not painted. If you want it painted, we can talk to you about that. Or if you want to install it and paint it later, have at it.
Awesome.
Just don't paint the label, because someday you're going to want to know what size meter that was and when it was installed. Just don't paint the label.
Great. Well, thank you again, Mark, for being here. And a big thank you to everyone that attended. We certainly appreciate your time. Hopefully you got something out of it. Hope to see you at another session later today or tomorrow. Everyone have a great afternoon. Thank you.
Thank you, Daryl.